Question number 19. There are two spheres. So we have a sphere A and we have a sphere B. A sphere A is having a radius of 400 r and a sphere B is having a radius of r. And sphere A is emitting radiation power is given as a 10 power 4 into E, and this one, that is sphere B, is having a radiation power as a E. సో ఫైనల్గా ఈ ప్రాబ్లంలో టూ కాన్సెప్ట్స్ ఇన్వాల్వ్ అయ్యి ఉన్నాయి. కాన్సెప్ట్ 1 వచ్చేపాటికి స్టీఫెన్ లా అండ్ కాన్సెప్ట్ 2 వచ్చేపాటికి వీన్స్ డిస్ప్లేస్మెంట్ లా. సో ఫస్ట్ టాపిక్ డిస్కస్ చేద్దాం, దాని తర్వాత లెట్స్ గో విత్ ద ప్రాబ్లం. సో దెర్ ఆర్ టూ థింగ్స్ వీ హ్యావ్ టు అండర్స్టాండ్. వన్ ఈజ్ స్టీఫెన్ లా. సో దెర్ ఆర్ టూ థింగ్స్, వన్ ఈజ్ స్టీఫెన్ లా, అదర్ వన్ ఈజ్ అ వీన్స్ డిస్ప్లేస్మెంట్ లా. ఈ స్టీఫెన్లో ఏం చెప్పింది అంటే, ఫర్ ఎగ్జాంపుల్ ఏదైనా ఒక బాడీకి ఒక స్పీర్ ఉందనుకోండి, స్పీర్కి ఎంత కొంత టెంపరేచర్ ఉంది అనుకోండి. ఈ స్పీర్కి లెట్సే టెంపరేచర్ T ఉందనుకోండి. సో టెంపరేచర్ ఉన్న ఏ బాడీ అయినా సరే రేడియేషన్ ఎమిట్ చేస్తూ ఉంటుంది. సో దీని నుంచి వచ్చే ఎమిషన్ ఎనర్జీ ఆర్ రేడియేషన్ ఎనర్జీ, దట్ రేడియేషన్ ఎనర్జీ ఈజ్ డైరెక్ట్లీ ప్రపోర్షనల్ టు T⁴. ఈ స్పియర్ నుంచి వచ్చే రేడియేషన్ ఎనర్జీ అనేది దాని యొక్క టెంపరేచర్కి దాని టెంపరేచర్ పవర్ 4 ఉంటుంది. సో టు రిమూవ్ దిస్ ప్రపోర్షనాలిటీ వీ రైట్ స్టీఫెన్ కాన్స్టెంట్, దట్ ఈస్ E ఈజ్ ఈక్వల్ టు వీ హ్యావ్ అ సిగ్మా T⁴. ఇప్పుడు ఈ వచ్చిన ఎనర్జీ అంతా కూడా, లేకపోతే రేడియేషన్ ఎనర్జీ అంతా కూడా, దట్ ఈజ్ ఓన్లీ పర్ యూనిట్ టైమ్ అండ్ యూనిట్ ఏరియా. అండ్ యూనిట్ టైం. సో ఇప్పుడు ఫైనల్గా ఓవరాల్ మొత్తానికి కనుక్కుంటే, అంటే కంప్లీట్ ఏరియా కనుక్కుంటే, వీ హ్యావ్ అ E ఈజ్ ఈక్వల్ టు సిగ్మా ఇంటూ A, వీ హ్యావ్ అ T⁴. సో దట్ ఈజ్ అ రేడియేషన్ ఎనర్జీ దట్ వాజ్ comes out due to the body which is having a temperature T. So that is the one formula that you have to remember to solve this problem. So that is E is equal to sigma into A T⁴. And one more is the Wien's displacement law. So that is the one more concept that involves here, Wien's displacement law. So one more concept is Wien's displacement law. సో ఈ వీన్స్ డిస్ప్లేస్మెంట్లో ఏం చెప్పింది అంటే, ఇఫ్ యూ డ్రా ద గ్రాఫ్ బిట్వీన్ దీస్ టూ, రేడియేషన్ ఇంటెన్సిటీకి యాజ్ వెల్ యాజ్ వేవ్ లెంత్కి, ఈ రెండింటికి గ్రాఫ్ని డ్రా చేస్తే, సో ఇఫ్ యూ డ్రా ద గ్రాఫ్ బిట్వీన్ దిస్ ఇంటెన్సిటీ, రేడియేషన్ ఇంటెన్సిటీకి యాజ్ వెల్ యాజ్ వేవ్ లెంత్కి గ్రాఫ్ని డ్రా చేస్తే, ఇఫ్ యూ హ్యావ్ అ లెస్ వేవ్ లెంత్, సో ఇదంతా కూడా లైక్ ఎక్స్పెరిమెంటల్ అనాలిసిస్. సో వేవ్ లెంత్ అనేది తక్కువ ఉన్నప్పుడు మనకి ఈ ఇంటెన్సిటీ పీక్ అనేది ఎక్కువగా ఉంటుంది. అంటే ల్యాండా అనేది తక్కువ ఉంటే ఇంటెన్సిటీ ఎక్కువ ఉంటుంది. నథింగ్ బట్ ఇంటెన్సిటీ ఎక్కువ ఉంది అంటే, రేడియేషన్ ఇంటెన్సిటీ ఎక్కువ ఉందంటే ఆటోమేటిక్గా టెంపరేచర్ కూడా ఎక్కువ ఉన్నట్టే కదా. సో దేర్ ఫోర్ దే కంక్లూడ్ దట్ దిస్ ల్యాండా ఈస్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు ద టెంపరేచర్, లేకపోతే వి కుడ్ సే దట్ ల్యాండా T ఈజ్ ఈక్వల్ టు సమ్ కాన్స్టెంట్. So this is a Wien's displacement law. Now in order to solve this problem, we're gonna use these two concepts. ఒకటి స్టీఫెన్ లా, ఇంకోటి వచ్చేపాటికి Wien's displacement law. స్టీఫెన్ లా ఫార్ములా సిగ్మా A T⁴, అండ్ Wien's displacement ఫార్ములా lambda T is equal to constant. Clear? సో ఈ రెండు కాన్సెప్ట్స్ యూజ్ చేసి we're gonna solve the problem. Right. So first one, where lambda A and lambda B are peaks in their radiation, అయితే we have to find out lambda A by lambda B. We have to find out that wavelength of that radiation which is emitted by the two spheres. So therefore, coming to the Wien's displacement law, I'm gonna solve the problem. So లాజిక్ నెంబర్ 1 అనుకోండి. లెట్స్ సే ఐ హ్యావ్ అ లాజిక్ నెంబర్ 1. సో సిన్స్ వీ హ్యావ్ అ ఎనర్జీ ఈక్వల్ టు సిగ్మా A T⁴. Therefore radiation energy due to this A is equal to sigma a Ta power 4. And since the radiation or radius is also changing, since the radius is also changing, therefore I can write it as a sigma, that speed radius, right? So nothing but 4 pi r square. We have a 4 pi. You could say that there is nothing but a 400 or 4 pi r square into we have a Ta power 4. So that is the energy radiation due to this A. Coming to the B, we have a EB equal to same sigma is sigma, and A can be written as a 4 pi r square into we can write as a TB power 4. If I divide these two, I have a EA by EB. I know this EA is nothing but a 10 power 4 E by have a E. That will be equal to, I could write it as a sigma cancel, 4 pi cancel, r square also cancel. Therefore I can add the 16 into I can add the 10 power 4 into I can add the Ta by Tb whole power 4, right? So this E get cancelled, and this 10 power 4 get cancelled. Therefore I can add as a Ta by Tb equal to I can add as a 1 by 16 whole power I can add as a 1 by 4. Therefore I can write it as a Ta by Tb can be written as a 1 by 2. So that is from a Stephen law. Therefore from what? From Wien's displacement law, we can write a relation between this lambda and the temperature. Therefore let me take a pen. So I have a lambda. Since lambda is inversely proportional to temperature from a Wien's displacement law, I can write lambda A by lambda B will be equal to I can add as a temperature of a B by temperature of a A. So that lambda A by lambda B will be equal to I can write as a 2. So therefore the answer for this problem is 2. And there are let me highlight these formulas. So one formula is this one that we used, and other formula is this one, that is one is the Stephen law, other one is the Wien's displacement law. So that's the answer for this. Answer is lambda A by lambda B is equal to 2, right? See the next one. So next problem is this one. Look at the question. ఒక సైడ్ ఏమో 0 degrees of ice ఉంది, ఒక సైడు 0 degrees of ice ఉంది, ఇంకో సైడ్ వచ్చేపటికి ఇంకో సైడు 100 degrees Celsius ఆఫ్ వాటర్ ఉంది. ఆ 0 degrees of iceని 100 degrees Celsius ఆఫ్ వాటర్ని లైక్ జాయిన్ చేస్తూ మధ్యలో ఒక రాడ్ ఉంది. అయితే if equal amount of ice and water melt and evaporated per unit time, find the lambda. So ఐస్ ఎంతైతే మెల్ట్ అవుతుందో వాటర్ కూడా అంతే ఎవాపరేట్ అవుతూ ఉంది. సో దట్ వీ హ్యావ్ టు క్యాలిక్యులేట్ we need to calculate that lambda, and there is a one more value that I missed to write here. So it is mentioned in the question, the temperature here is 400 degrees, where the temperature at the point P is 400 degrees Celsius. అయితే we have to find out a lambda. Repeating a question, ఒక సైడు 0 degrees of ice ఉంది, ఇంకో సైడు 100 degrees Celsius ఆఫ్ వాటర్ ఉంది. ఆ టూ థింగ్స్ని జాయిన్ చేస్తూ ఒక రాడ్ ఉంది, అండ్ దట్ రాడ్ ఈస్ హ్యావింగ్ ఎ లెంత్ యాజ్ 10x. సో P అనే పాయింట్ దగ్గర టెంపరేచర్ 400 degrees Celsius ఉంది. అయితే ఇప్పుడు ఈక్వల్ అమౌంట్ ఆఫ్ ఐస్ అండ్ ఈక్వల్ అమౌంట్ ఆఫ్ వాటర్ ఎవాపరేట్ అవుతున్నాయి పర్ యూనిట్ టైం. దెన్ వీ హ్యావ్ టు ఫైండ్ అవుట్ అ లాంబ్డా వాల్యూ. దట్స్ ద క్వశ్చన్, రైట్? సో నౌ ఇక్కడ యూజ్ చేయాల్సిన కాన్సెప్ట్స్ ఏంటి? కాన్సెప్ట్ ఏంటి అంటే, ఒకటి latent heat of evaporation and latent heat of fusion. You know very well those both topics. Let's discuss the topics first, then we will solve the problem. Let's talk about it. So one is a latent heat of a evaporation. So what is the meaning of latent heat of a evaporation? Latent heat of evaporation is the heat that is needed to change 1 gram of uh, 100 degrees Celsius of water to 100 degrees Celsius of a vapor. Let me write. So latent heat of evaporation మాట్లాడుతున్నా 1 gram of 100 degrees Celsius వాటర్ని తీసుకొని అండ్ దీన్ని 1 గ్రామ్ ఆఫ్ 100 degrees Celsius ఆఫ్ స్టీమ్ కింద కన్వర్ట్ చేయాలి. 100 degrees Celsius ఆఫ్ స్టీమ్ కింద కన్వర్ట్ చేయాలి. సో in order to convert this 100 degrees Celsius of water to 100 degrees Celsius of steam without any change in the temperature. సో టెంపరేచర్లో చేంజ్ ఏమీ లేకోకుండా అలా కన్వర్ట్ చేయాలి, లేకపోతే ఫేజ్ మారకోకుండా టెంపరేచర్ మారకోకుండా ఫేజ్ని చేంజ్ చేయాలి. అలా చేంజ్ చేయడానికి యూ నీడ్ టు ప్రొవైడ్ సమ్ ఎనర్జీ, దట్ ఎనర్జీ ఆర్ యూ నీడ్ టు ప్రొవైడ్ సమ్ హీట్ ఎనర్జీ, దట్ ఎనర్జీ ఈజ్ కాల్డ్ యాజ్ ద latent heat of evaporation. సో నార్మల్గా అది వాటర్కి వచ్చి 540 calories per gram ఉంటుంది, రైట్. సో దట్ ఈస్ ద latent heat of evaporation. రిపీటింగ్ వన్ మోర్ టైమ్, 100 degrees Celsius ఆఫ్ వాటర్ని 100 degrees Celsius ఆఫ్ స్టీమ్ కింద మార్చాలి వితౌట్ ఎనీ చేంజ్ ఇన్ టెంపరేచర్. యూ నీడ్ టు చేంజ్ ఓవర్ ద ఫేజ్. ఏ ఫేజ్ నుంచి ఏ ఫేజ్ వరకు అంటే లిక్విడ్ నుంచి వేపర్కి. సో ఇది వాటర్కి వచ్చేప్పటికి 540 calories per gram ఉంటుంది, రైట్. So you can also write this formula as Q is equal to, or you can also write that latent heat of evaporation as, you can write as a Q by M, or else you can write this Q is equal to, you can write as a M into L. In the same way, coming to this latent heat of fusion, so let's say we have a 1 gram of ice at a 0 degrees Celsius. సో ఐస్ అంటే సాలిడ్ స్టేట్లో ఉంటుంది. నౌ వీ హ్యావ్ టు కన్వర్ట్ దట్ ఐస్ ఇంటూ 1 gram of వాటర్ at 0 degrees Celsius. Same. So we are changing a phase from solid to liquid without any change in the temperature. So here this is called as a latent heat of fusion. సో ఐస్కి వచ్చి latent heat of fusion అంటే సో అరౌండ్ 80 calories per gram ఉంటుంది. కీప్ దట్ ఇన్ మైండ్. సో దిస్ latent heat of fusion can also be written as, we have a Q by M, and therefore we have a Q is equal to M into LF. So this is the concept that we're gonna use. There is a one more concept, that is heat transfer. So you guys already know that heat transfer. In a heat transfer, this transfer of a heat per unit time, we have a dq by dt will be directly proportional to few things. One is that will depend upon a area, or directly proportional to area, and this dq by dt directly proportional to change in a temperature, and this dq by dt is inversely proportional to the length of that particular object. So these are the three factors that will decide the rate of change of a heat through a body. If we combine all of them and write, we have a dq by dt is directly proportional to a delta t by L. To remove this proportionality, we have a dq by dt will be equal to k a into delta t by L, where this k is called as a conductivity, and keep that in mind, right. So these are the concepts that you need to understand in order to solve this problem. So let's solve the problem now. One second, let me delete. Yeah, right. So let's solve the problem. One side 0 degrees of ice ఉంది, ఇంకో సైడ్ అదర్ సైడ్ 100 degrees Celsius of water ఉంది. So we have a rod in between them. So that the point P is having a 400 degrees Celsius of temperature, right. So now according to the first logic, or according to the given logic in the question, he is saying that let's say we have a Q is equal to M into L or M into LV. Therefore we have a, if I write it as dq by dt, let's say we have a logic number 1, we have a dq by dt is equal to, we have a dm by dt, we have a dm by dt into, we have a L into V, right? So in the second one we have a dq by dt, we have a dq by dt is equal to, same again we have a dm by dt, but this time we are talking about a ice that was melting, therefore we are writing it as a LF. So that's a logic number 1 and a logic number 2, and I have a logic number 3. So there is a heat transfer from this point P to the ice side. Let me draw it in the diagram, let me show it in the diagram. So from here there is a heat transfer like this from P to that ice, therefore I can write this dq by dt as from that heat transfer concept. From that heat transfer concept I can write this dq by dt as, we can write this dq by dt as, I can write the dq by dt as what? K into A, I can add the delta t, where delta t is nothing but a 400 minus 0 by half a length, so that length is given as a lambda x. In the same way from here to here, from 100 to this P point, there is again a heat transfer, right? Sorry, from this side, my mistake, this side there is again a heat transfer, that is I have a logic number 4, again we have a dq by dt, again we have a dq by dt is equal to K into A into, so I could say that this is nothing but a 400 minus 100 by, so this length is given as 10 minus lambda into x. Clear? So therefore since this dm by dt and dm by dt they both are equal, right? From here if I write this dm by dt as, since this dm by dt are equal, I can write as a dq by dt, I can write as dq by dt into I have a 1 by LV, sorry, into I have 1 by LV equal to I have a dq by dt into, I can write as a 1 by LF, right? So dq by dt can be written as K here, A here, 400 minus 100 by, I have a 10 minus lambda into x into I have a 1 by LV, can be written as a 540, will be equal to this side I can write as a K into A into, I can write as 100, sorry, I can write as a 400 by, I can write as L as lambda into x, and this can be written as a 1 by 80. So therefore you can cancel out this Ka, you can cancel out, what else remaining cancel, nothing is cancelled, you can cancel out this 0 and 0, and if you do this calculation you will get this lambda value, you will get that lambda value as a 9, you will get this lambda as a lambda value as 9 if you do the calculations. So that's question number 20, that involves both this latent heat of vaporization, fusion as well as the heat transfer. So that's the question number 20. Next, see this question. So there is a diagram shown like this, right? So one side we are having a temperature as 100 degrees Celsius, and other side we are having a temperature as 0 degrees Celsius, and we have a like a circle here, so that is a B2C, and we have from this side also we have a B2C, right? Then we have to calculate the temperature at a point C, we have to find out a TC, we need to find out a TC, right? So for this again we're going to use that heat transfer topic, that is from conductivity. So let's talk about the basics, then we'll solve the problem. Let's talk about the basics first. So just I told you already this topic, just now I told you, that is this dq by dt or heat transfer. One second. this dq by dt will be equal to, I have a k a delta t by L, and this dq by dt can be written as a heat transfer per unit time, or else let me say that some heat current, let me represent with the h. H is equal to, I have a delta t by, so we have a L by Ka, right, and I have a H is equal to, I can write as delta t by R. So now if you compare this equation with this current equation in a current LCT, therefore you can write the delta V by, we can write as R. So here if you relate these two equations, we could say that this current and heat, they both are same. If you relate these two, these two are same, that is heat and current are same. And if you relate these two, this delta T and delta V are same. And if you relate these two, this R and R, they both are same. So therefore here this R value, that is R is equal to L by Ka, is called as the thermal resistance. So keep that in mind. R is equal to, we have a L by Ka. So whenever we have some rod which is transferring some heat, will have some thermal resistance. That is the main thing that you have to keep in mind here. Therefore we have a one rod here, there is a rod here, there is a rod here, there is a rod here. So therefore we have a resistance here, resistance here, resistance here, as well as a resistance here. So we're going to solve this problem by using this concept of heat current, thermal resistance, and temperature change. We're going to use it. So that is the topic which is going to involve in the problem, right? So let's solve the problem. So now this problem seems like this. If you go with this electrostatics, that is not electrostatics, in the current electricity, that is simple. So let me say there is a resistor here, there is a resistor, and one second, sorry. So there is a resistor here, there is a one resistor, and there is a one more resistor here, there is a one more resistor here, and there is a one more resistor here, right? So let's say it is having resistance as R, and it will have a resistance as a pi R, and it's a resistance as a pi R, and it will also resistance as a R. Therefore we have a R equivalent as, R equivalent is equal to, I have a 2R plus let's say we have a pi R by 2, right? So since the both are in a parallel combination, therefore I could say that this R equivalent is equal to, I have a 4R plus pi R by 2. If I take out this R common, I'll have a 4 plus pi by 2. So that is the equivalent resistance, R equivalent. That is the thermal equivalent resistance. So R is equal to 4 plus pi by 2. Right, we're gonna solve this problem by using this current electricity topic. That is what I mean. So now there is a temperature difference. For example, now here this point is having a temperature as 100 degrees Celsius, and this point is having a temperature as a 0 degrees Celsius. Nothing but we are gonna like assume them as a 100 volt here and a 0 volt here. Therefore the overall current which is passing through this will be equal to, or overall heat which is passing through this will be equal to, I have a H is equal to, how much is it, temperature difference is 100 by resistance is let's say R, 4 plus pi by into 2, therefore that will become a 200. So that is the heat, that is the overall heat that is flowing, that is it is flowing in a wire. So this is the heat that is flowing in the complete wire. So now we have to find out the temperature here, or we need to find out a temperature at a point C. We have to calculate the temperature at a point C. And for this rod, if I draw this line equation, like if I have a delta V is equal to, I could say that delta V is equal to, I can write as I into R. Like in a current electricity, the voltage drop across that resistor can be written as delta V is equal to I into R. So delta V can be written as, let me say, it is nothing but a Tc minus 0 degrees will be equal to I. I can be written as 200 by r into 4 plus pi, right, into this resistance of this one. Since this L is directly proportional to R, so resistance will be R. Therefore, you could say that R here, so this R get cancelled. Therefore, I have a TC will be equal to 200 by, we have a 4 plus pi, that will be equal to around, that will be around 28 degrees Celsius. This will be around 28 degrees Celsius. So that's this question, so which is important. Next question. So it's also similar to the same concept. So you could see clearly. So one end is having a 60 degrees Celsius, other one is having a 10 degrees Celsius. So we have to calculate the temperature TB, or we have to calculate the temperature at a point B. I forgot to indicate a B here. So this is the point B, right? So that's a point B. There you have to calculate a temperature. There you need to calculate temperature, and he has given a condition as a conductivity of X is 2 times of a conductivity of Y, right? So we already know the concept well, that is, it is almost like thermal resistance concept. It's almost like thermal resistance concept, but there is only one logic that you need to understand. Hope you know that thermal resistance formula. Thermal resistance formula, I have R is equal to L by, I have a K A. So here this R is inversely proportional to the conductivity, right? So this K is having a more conductivity, the resistance will be less, and Y is having a less conductivity, the resistance will be more. Therefore, you could clearly say that resistance of X will be equal to R, and you could say that resistance of Y will be equal to 2R. So that's the only one logic that you need to understand. Repeating the logic, R equal to L by Ka, so that is the thermal resistance. So since this R is inversely proportional to the thermal conductivity, and a given condition is conductivity of X is 2 times of a conductivity of Y. Therefore, since this X is having a more conductivity, that will have a less resistance, and since Y is having a less conductivity, that will have a more resistance. That is the only one logic that you need to understood here, right? If you understand the logic, then let's solve the problem. So let's say like again by using this heat current. So it is a one resistor, and there is a resistor here. One second, sorry. So there is a resistor here, and there is a one more resistor here. There is a one more resistor, and one more resistor, and a resistor, right? So it is having a temperature as a 10 degrees Celsius. It is having a resistance R. This resistor is R, this resistor is 2R, this resistor is 2R, and this resistor is 2R, and this resistor is R. This temperature is 60 degrees Celsius, and this is a point P. That's a point B here. If you could see that according to this Wheatstone bridge, so this 2R, and it is R. So therefore it's like balanced Wheatstone. Therefore there is no heat current that is flowing through this middle rod. Therefore you can eliminate that middle rod. If you eliminate this middle rod, so this upper resistor will have a net as 3R, and that down one will also have a 3R. Therefore you could write it as, like, if you redraw the diagram, that will be like this is R, and this is 3R by 2. That is R, and this is a 3R by 2. So this is a 3R by 2. It is having a temperature as a 60 degrees Celsius. It is having a temperature as a 10 degrees Celsius, right? Now this R and 3R by 2, if you take it as a net for R and 3R by 2, that will be equal to 5R by 2, right? So therefore this net resistance will be like, so you have a 60 degrees here and you have a 10 degrees Celsius here. This will be like 3R by 2, therefore we have a 5R by 2. 5R by 2, therefore the current or heat that is flowing through this whole wire can be written as 60 minus 10, 50. 60 minus 10, it is 50. So 50 by resistance, nothing but 5R by 2, therefore that will be 100. But I have a 5R, therefore I have this current as 20 by R. That is the current flowing in the wire. Now if you find out a drop over here, the drop at this resistor, we can write as this delta V is equal to, we can write as the I into R. So delta V is, I have a 60 here, I don't know how much here will be, I don't know what this B is. So I have a 60 minus something like a T will be equal to, I can be written as, what is I? 20 by R. So I have a 20 by R into this resistance is R again, this one cancel, therefore I have a T is equal to 40 degrees Celsius. So that's the next question. Answer is, so therefore temperature at a B is equal to 40 degrees Celsius. Clear? So this problem, so there is a rod and the rod చుట్టూ ఒక ఇన్సులేటింగ్ మెటీరియల్ ఉంది అండ్ ఆ రాడ్లో కరెంట్ పోతుంది. కరెంట్ ఎంత అంటే 5 amperes and that rod is having a resistance as a 4 ohms. అయితే we have to find delta T across the insulator in a steady state. So steady state లో we have to find out what do you call temperature difference between these two things. ఈ ఎండ్కి మధ్యలో ఉన్న డెల్టా టీ అంతా కనుక్కోవాలి. ఈ ఎండ్కి మధ్య ఉన్న డెల్టా టీని కనుక్కోవాలి, రైట్? సో దట్ ఈస్ వాట్ వీ హ్యావ్ టు క్యాల్కులేట్. దట్ ఈస్ వాట్ యూ నీడ్ టు క్యాల్కులేట్. సో లెట్స్ సాల్వ్ ద ప్రాబ్లమ్. దీనిలో కొత్తగా నేర్చుకోవాల్సిన బేసిక్స్ అంటూ ఏమి లేవు, బట్ యూ నీడ్ టు అండర్స్టాండ్ హౌ టు ఇంటిగ్రేట్ ఇట్ అండ్ వాట్ టు టేక్. Therefore let's solve this. So if you look at a front face of it, or else like this seems like, and here it seems like this, right? So let's say this inner one is having a radius R and outer one is having a radius R1. So this is inner and this is outer. So inner one is having a radius R1 and outer one is having a radius R2. So this is having radius R1 and it is having a radius R2. Now what you are doing is we are taking a small element. We are gonna take a small element. We are gonna take a small element which is having a radius as R and thickness as a dr, right? So let's say it's having a thickness as a dr and let's say it is having a radius as R, right? Now since the heat transfer is flowing through this one, like let me draw it. So since it is flowing like this, like it is flowing across it, we gonna apply this heat transfer concept, that is delta Q by delta T or dQ by dt is equal to K A delta T by L, right? We're gonna use this topic, we're gonna use that topic here, that is heat transfer topic. Therefore we know that this heat current or dQ by dt can be written as a H is equal to K A delta T, I can write as a delta T by, I can write as a L, that is a general formula. Here I'm writing H is equal to K, I'm writing it as a K only, and A can be written as, so since that is like I can write as a 2 pi R into dr, or since I'm taking a whole length, So you're gonna write as a 2 pi r into I have a this length is given as something whatever, let me take it as a L into delta t. So for example here between these two or between this one, let's say I have a temperature difference as the dt by I have a length as a, now this length, I mean that element length is nothing but a dr, that element thickness is the dr, so that is the formula of it. That is the main now we have to integrate it. Now we need to integrate it, therefore I can write as a dr by r. Dr by r is equal to, I can write as what, k 2 pi L as it is, I can write as a dt by h. I have to integrate it from r1 to r2, and this is dr by r, that will be equal to k 2 pi L by h for a constant, so bring out them, integral of dt. So let's say we have a t1 here, let's say we have a t2 here. Now this can be written as ln, we have r2 by r1, that will be equal to, we have a k 2 pi L by we have a h into this t1 to t2 dt, that can be written as a t2 minus t1, that is what we're going to calculate, have a t2 minus t1. Therefore we can write as a t2 minus t1 will be equal to h into ln, I have r2 by r1 by I have a k2 pi L. So you know all the values, substitute them and you will get the value. You will get the value as this delta t approximately, if you calculate all the values, that will be equal to, this delta t will be equal to 2 degree Celsius. So that's the question, and here you need to only understand this one, that is how we has taken that small element and how we integrate it for temperature difference. Clear? So this question, so we have a furnace, left side lo furnace undi with the temperature of 800 Kelvin, and right side lo vachepatiki we just connected one rod, let's say we just connected one rod, and that rod one end is having a temperature of 750 Kelvin, and our surrounding lo we have a temperature of 300 Kelvin. Aithe if radiation is only mode of energy transfer, then we have to find thermal conductivity of a rod. We need to find out a thermal conductivity of a rod, so therefore here there is a heat transfer in this direction, there is a heat transfer in this direction, there is a heat transfer in this direction, so this directional heat transfer that is from 800 to 750 Kelvin. One side we are having a temperature of 800, other side we are having a 750 Kelvin. Therefore by using this heat transfer concept, I can write that heat current formula as, you know already heat current formula. This is the fourth or fifth problem that we are solving on that heat transfer concept. Therefore I have a heat current formula, let's say H is equal to, I have a K into A into I have a delta T by, I could say that I have a length as L, or else I can write this heat current also, they both are same, but let me say I have a dq by dt is equal to K A delta T by L, right? And here we are having saying it is a radiation, so therefore there is a loss of heat due to this radiation. We have a dq by dt, this can be written as by using a Stephen's law, we can write as a sigma A, we have a t power 4, like we have a t power 4 minus, or I could say that t is surrounding power 4. If we equate these two, we have a Ka delta T by L, that will be equal to sigma A, we have a t power 4 minus, we have a ts power 4. So this A get cancelled over, and a K, this can be written as temperature difference between 800 and 750 is nothing but a 50, by this L can be written as 20 centimeters is nothing but 0.2 meters, will be equal to sigma. There sigma is provided, I forgot to represent here. I have a sigma is equal to 6 into 10 power minus 8 watt per meter squared t power 4. So if you substitute that value, sigma into, we have a 10 power 8 into t power 4, which is nothing but a 750 power 4 minus, I have a 300 power 4, right? So let's say this can be written as 6 into 10 power 8. This can be written as a 7.5 into, you can write as a 10 square minus, you could say that 3 into, you can write as a 10 square, that is whole power 4 here, again whole power 4 here. Therefore you can write as a 6 into 10 power 8. This can be written as a 7.5 whole power 4 minus 3 whole power 4 into, you could write as a 10 power 8. Here it is a minus 8 and minus 8. Therefore this one get cancelled. Therefore you get k value as approximately 74 if you do the calculation by substituting other values, right? So there is a one more problem here that was given in a paragraph. So there is a diagram which is having a circle, and its circle is, or a ring is divided into 3 parts. Let's say AB is a one part, BC is a one more part, and this AC is a one more part. Then we have to check these 4 options. First option is Q1 equal to Q2 is equal to Q3 and all are in a clockwise. Second option is Q1 and Q2 are clockwise and Q2 is anti-clockwise. Third option, Q1 is to Q2 is to Q3 is alpha 1 is to alpha 2 is to alpha 3. Q1 by alpha 1 plus Q2 by alpha 2 is equal to Q3 by alpha 3. Actually it changes the question here. I just represent this alpha 1, alpha 2, alpha 0, K3. Therefore here also this should be alpha, this should be case, not alphas. Now let me see. I have a K1 is to K2 is to, I have a K3, and here also same like this. I have a Q1 by K1 plus Q2 by K2 will be equal to Q3 by K3. Right. Now we have to check all these 4 options. So first option, like let's say it is having a 120 degrees Celsius. Let's say it is having a length L. It is also having a length L. It's also having a length L. So all will have a same equal length. Again, it is a heat transfer concept, like a heat current concept that is already we discussed in our previous problems, right? So that is this heat current, I have a H is equal to, K A delta T by L. Therefore this heat, I have a H1 will be equal to, this K can be written as a K1 and A can be written as, let me say it is A only, delta T can be written as 50 by, I have a length as a L, that is this one, the heat transfer here, that will flow from high temperature to low temperature. And I have a H2, that H2 is equal to, I can write as a K2A, and again I have a 50 by, have a L. So it will flow in a clockwise, high temperature to low temperature, that will also flow in a clockwise, high temperature to low temperature, that is from 50 to 0. And here I have a heat 3, that H3 is equal to same, that is I have a K3, A is A, temperature difference is 100, and because of here it will flow from A to C, not C to A, that is high temperature to low temperature, 100 by have a L, that will flow in a anti-clockwise, right? Therefore this Q1, Q2, Q3 they are not equal and all are in a clockwise, so this option is wrong. Q1, Q2 clockwise and Q2 is anti-clockwise, so Q1, Q2 are clockwise, Q2, 3 is anti-clockwise, so that is the right. and q1 is to q2 is to q3. So if I just if I write as a h1 is to have a q2 is to have a h3, that will be equal to, I could say that is nothing but a k1 is to k2 is to have a 2k3. So therefore this last option is, sorry, the third option is wrong. What about the fourth one? That is I have a h1 by k1 plus I have a h2 by k2 plus I have a, sorry, that should be equal to h3 by k3, right? So I know h1 can be written as k1 a 50 by l. So k1 cancel, that is nothing but a 50 a by l, right? Plus second one is also same, that is 50 a by l, right? That will be equal to 100 a by l. Therefore this third option is, sorry, fourth option is right. So this second option and the fourth option is right. Clear? Right.